Good evening. How many people have not seen Endgame yet? How many people have tickets for later? Okay, so there's not a lot of pressure because I have between 20 minutes and 2 hours worth of content. Because this is what happens when you move from an organization where it's like, oh yeah, present whatever you want, to, oh no, you shall get this approved. So, and oh, by the way, you must submit your content at least a week before you need to speak about it. So I had slides without a talk. So I work at Google. I work in the cloud area. Bridget and I actually used to work together at a company called Pivotal that Merrill was a customer of. They run the Cloud Foundry product. You probably also run PKS. And so a lot of, and by the way, they're a partner with Google in the Knative project. And I think we jointly announced it with them last year at Google Cloud Next. I'm deathly afraid to speak, so like if I talk too fast, Bridget's going to point at me and go, slow down. Plus, I also want to get you to see Endgame. But one of the things that's really hard in a multi-cloud world is understanding what your units of portability are, and really about how you make your developers more productive. And so the reason I have this context setting slide in is because I didn't know if I was going to need it, but serverless is about the most overloaded term in everyone's world, meaning like when I think of serverless, are you thinking there's no server somewhere? Are you thinking of like database as a service, software as a service? Because all those things are kind of serverless, and so it's important to do some context setting. And like the reality is serverless is running a workload without caring about like what's underneath it. So there's lots of products in this space. Every cloud provider provides a bunch of things all the way from APIs to I'd like to have a database as a service and not have to worry about like replication and like, oh my God, like all those things that like everybody in the room who's ever had a problem with a database, raise your hand. Everybody in the room who's ever had a problem with a half-completed Oracle rack cluster having a disk failure in it and losing all of your transaction log for about the busiest peak season, raise your hand. So there's still servers somewhere. Just people who are really, really good at it and are just allowed to focus on that are somewhere. And so there's this notion, and this is a slide I stole from my prior employer and then redrew because can't get it through approval if it's somebody else's. But there's this notion of all the way down to the hardware level, there are various abstraction layers that kind of roll up all the way to function, which is what everybody has kind of been thinking of as this is what serverless is I have this function thing. The important thing to notice about this drawing is if it was in 3D, like some of that stuff underneath that may be present when you actually build serverless. Like maybe you've got this magic world where you have a container OS running on your hardware, but like your function gets packaged into a container somehow, and then you run that on the container OS that's running on your hardware. Guess what? To the person who actually creates the container and pushes it, if they don't have to care about container OS on the hardware, to them that's serverless. So the idea on this slide is really about like the further you move up this thing, the more efficient you are from a certain context. Like if I'm only writing one function, I'm ridiculously awesome. I wrote a line of code, I got it deployed, it worked. Now, is it worthwhile? I don't know. You have to plug a whole bunch of those things together. So the lower down you have, you are more flexible. The higher you are, more standards. So the idea is we want to free our devs from the burden of doing things that aren't part of their core business goal. Like when you have somebody who writes a web page, like should they have to worry about how the web server works in an ideal world? Yes, they should, because they should program it to work with that. But should they be burdened with the operation of that every day? Probably not, because you want them writing code. And then we move to the world of like what we traditionally think of, which is small single-purpose functions that are invoked in response to events that like don't just sit around and wait. Like when you start a web server, it's sitting there and it's like, somebody please make a request. In the serverless world, there's still something doing that, but it's not necessarily your function. And so I like to use plumbing metaphors because my dad literally wrote the book on plumbing. well, not anymore. Somebody else ghostwrites it for him. But if you want to be a plumber in this country, you have a 1 in 2 chance of using my father's textbook. So, but developers are most effective for the business when they're focused on business problems. They're also more effective because we tend to be we like artisanal servers. We like artisanal things. I want to figure out how all this works, which is why I'm giving a talk tonight, because I wanted to figure out how well this worked. I don't actually focus a lot on this because we don't actually sell this as a product. We will wrap this up and we will sell it as something else. By the way, it's called Cloud Run. We just announced it last week. It's beta and it's new. What I'll say is it's not fully featured yet. But in the world of your developers, because they like to care about artisanal things, if there's not enough ease through automation, your developers are going to write some of this themselves. And that's all cool because we trust them all, but they're not always there when it's time to be paged. That needs to be darker. There's a pager in the background. And it's normally the ops team that gets paged, or there's somebody on the front line that's going to have to respond to somebody saying this is down, because they probably didn't write all the failover automation. That's something like, Google has this book we write about SREs where we talk about how we remove toil from things, and it's all about having effective monitoring and metering and being able to know when things are going to fall over before they happen or be able to react. It turns out, by the way, super secret world, Google's not the most stable platform in the world. You just never notice, or you hardly ever notice. So let's talk about a platform's overall goal being making the right thing to do, the easy thing to do. And this is something we used to talk about a lot about Pivotal, where they had a platform that had a lot of pre-built opinions in it that was all about constraints and guardrails that made the thing that the ops team wants you to do the thing that you get to do. So you're going to want a serverless platform. I like to use stages as my metaphor for platforms. I play the drums, so yeah, drums. And you're probably going to want to build it yourself. So Kelsey is in Google at DevRel. He's awesome. He's really good at recognizing patterns of things. And so, and by the way, this is when I worked at Pivotal, everybody was like, oh, your platform's so awesome. Can I talk to you about how the sausage is made? Mostly because I want to validate the thing I'm building myself, which is not a bad thing. It was frustrating to work there and have people come up and talk about really awesome ideas that they had that were really good for what they were doing and for their culture and their organization. And then we're like, oh no, just come in and use this thing that we've already pre-built for you. And it had some ability to be modified, but the reality is it's most effective if you use it the way that Pivotal built it for you, or the open source community. So why not Kubernetes? Well, as Kelsey likes to say, it's a better place to start, not the end game. And so it's kind of building blocks for building other things. Really, really smart folks can do lots of really, really cool things with it. Really smart folks can also do lots of really uncool things with it. It's a loaded gun. Choose how to use it. And it's also important to Dan Woods, formerly of Target, now of politics. Dan's back into politics now. Kubernetes, Target treats Kubernetes as an infrastructure control point. They actually don't expose it all the time directly to developers, and they're actually trying to move away from that. They're trying to build an opinionated platform where opinions are strongly held but loosely coupled or loosely held because it's an infrastructure and abstraction, and they want folks focusing on business value. And so they're doing a lot of work with something they call the Target Application Platform. They gave a talk about it at Google Cloud Next. I would highly encourage you to check it out. It's a very cool platform. It goes all the way from scaffolding to you have something running and it's monitoring, and it can go lots of places. So I'd encourage you to check it out. But so back to this, we're actually going to kind of focus on these top 2 layers here, function and application, with a little bit of containers mixed in, just because that's kind of the consumption pattern that Knative kind of starts to think about exposing to folks. So if we think about a serverless platform's coarse-grained requirements, and this is where Knative starts to come in. The platform should be able to take something that you want to run in some form of source, whether that be source code, or whether that be a container image, or whether that be a function, which is still source code, and package that into something that it knows how to run and monitor and meter and like do all the cool things with. And then deploy it and run it and like keep it running or scale it to 0 when there's no traffic that it needs to respond to, because like everybody likes to buy hardware. Like the poor person who has to worry about all those servers, like how much request traffic is running over the network? I don't know. And there's, we had this, I had a conversation with a particular customer last week where they go around their data center and they do something that I used to call a serverless utilization test, which is you walk up to a machine that you don't know what's happening to it, or you don't know if the stuff that's on it is being used, and you unplug the network cable and wait for people to start yelling. You put a little Post-it note on it so somebody who's freaking out about the fact that it's unplugged knows who to call. But then the other, the last piece of this is, once you have these things up and running, is you need to be able to map traffic to it, and then maybe get some events to some things that might want to respond to events. Those can be server requests, those can be messages. And so having a platform that can do all these things is really where Knative's trying to go. This is a little bit more finer grained version of this stuff, because this starts to get into a little more of the opinions that Knative holds about this stuff. So, a container creation and deployment process, scale to 0, handling of revisions, so that when the thing that you just rolled out isn't the thing that really you wanted to roll out, we have the ability to come back and maybe do some testing along the way. And then this is where Knative really starts to get powerful, where we start to get to talk about serverless, like an eventing system with configurable sources, flows, subscribers, ways to hook these independent functions together to respond to things in a way that makes sense for the application you're trying to build. Remember when I said, hey, I wrote that one thing of code and I got it deployed, and I'm like, ooh, I'm super successful? If nobody's calling that, you actually haven't delivered a single blick of business value. You actually consumed some power and you cost the company money. Our job as developer, who likes paychecks? I like paychecks. If you're in the retail business or you're in a service provider business, your job is to make sure that somebody gets some value that causes them to give your company money, so that can be converted into a direct deposit in your bank account. And then obviously you want something to collect metrics and export telemetry. Remember when I talked about site reliability engineering? In order to be able to determine whether your thing is running, the good old days of the, and we still have this in Kubernetes, which is the liveliness test, where it's are you still there? Are you still there? Are you still there? How often do you do that? But just because it's there, what if it's responding with a 404? By the way, Joe Biden launched his website, Politics. I encourage you all, if you are want good humor, just go to joebiden.com/bad site, because his 404 page is awesome. Almost as good as Homestar Runners, because it made me laugh. So we're finally to Knative. I'm 15 minutes in. Why Knative? Or what is Knative? How many people have heard of Knative? How many people have done anything with Knative? Oh, you get to come up and help me. So let's start with what Knative is not. And this, by the way, is super, this is the same thing of what Kubernetes is not. It's not a fully featured function as a service platform. You can probably expose it and somebody would be able to do something with that, but it's really intended to be a set of primitives that you would use to build some other opinionated system that to build a FAS, PaaS, application as a service, container as a service, something that can take something, run it, do all those other things. And so, Kelsey has a good thing, it's just specs and describes how to do this. And by the way, it's really immature. When we get to the eventing, when we get into the detailed crawling that we're going to do, because I like to crawl through details, I like to crawl through documentation, write slides, and talk to people about them. That's not necessarily, it doesn't necessarily make my company money, but I like to do it because I like to figure out how things work. We'll get into the eventing stuff is really super immature at this point in time. And by the way, the latest release just came with this, oh, hey, we forgot this thing. We just added it. But we didn't really explain what it does or how it works. You have to read through source code. So it's an abstraction on top of Kubernetes. It's going to deploy and run some containers. It can also build those containers for you. And it's going to abstract away a bunch of your stuff through custom Kubernetes API objects. So you're still going to call Kubernetes things, but they've written a bunch of these custom resource definitions that contain higher level abstractions that are primitives that you might use to do something like build a platform as a service or a function as a service. And then we've allowed it to, we've handed it off to other people, or the project has handed it off to other people. Like if Pivotal actually has an open source project called Project Riff, which is a function as a service platform that didn't start out on top of Knative, but it had a lot of input into what Knative is, and so it runs there now. So they have a function as a service platform that, like, give it a function, and it will build you a Riff-style thing, and it sits on top of all the Knative stuff. But 0.5, ooh. So things may not make it all the way through, but the spec is some of the specs are more solid than the others. And then this is like this middleware components, and these are lingo franca that they use on their website. So interesting font color change here. This apparently, not all these slides were reviewed. So the codified patterns, I'm going to skip through this because people want to get to endgame, but remember when we had these things? This is just a different way of saying these things. So we're going to deploy a container. We're going to be able to go from source to URL with workflows. We're going to be able to route and manage traffic. We're going to be able to split workload between running revisions of a thing, which, woohoo, that's awesome. And then we're going to scale and automatically size our workloads based upon like who's calling it. So, which, by the way, there's a complicated assumption in that, which is if your thing's not running and a request comes, what do you have to, like, somebody still has to catch that request and be like, oh, I'll hold on to this while that thing starts. But the idea is because it's Kubernetes, things are going to start really fast. And obviously, because it might be a function that's lighter weight, like if you're writing a Spring Boot application, oh, please wait while the container like loads and like all the things start. And oh, like making smaller things start faster enables you to like do more things. And then binding these run services to eventing ecosystems in some sort of way, shape, or form. So this is the expected usage pattern. Your developers sit up there. They can call any of these things they want. The lower they call on this stack, the scarier it gets for you, and the more opportunities they have to mess things up. So in Pivotal's world, when we built Cloud Foundry, there was like, I can't go all the way to the scheduler. I'm actually going to call this PaaS or FaaS or application as a service platform. And that's my developer experience layer. And I'm actually not going to allow them. There's other platforms, OpenShift is one of them, that takes a slightly different opinion of this, which is, well, really people are going to, like, they actually probably need for certain workloads to do some of these things. And so we're just going to expose that to them. That's not a bad pattern. Where that risk, though, is like anything, like what you want to do as an operator is anything that is this or this, like you own all that. Like I worked at a company in 2009 where it was like, hey, who can get a MacBook? Anybody who wanted to support themselves running on a MacBook could have a MacBook. So it was like, take your Windows machine and we'll support it for you, or take your MacBook and do whatever you want with it. But like when it's broken, like it's not our problem. And so as you move down these layers, you still want to provide them with support resources and the ability to troubleshoot things. But honestly, it's like, oh, you veered off the path. Like when you go off the trail in the woods, sorry, like we'll try and come find you, but you're there till we find you. So Kubernetes, run it somewhere, probably buy it from a platform provider, or if you're really, really good and you love open source, like Target is ridiculously good at running Kubernetes. They don't need to go out and hire or buy a packaged version of it, but it's a non-trivial thing, but they run a lot of it. Like there's one in every store. So like they're ridiculously good at running Kubernetes because they have to run a lot of it. The size of your company is going to directly dictate how good you're going to be at it because it's going to determine how many clusters you want. There is an emerging movement that suggests, like if you follow Jess Franz on Twitter, she used to talk, and I think she still talks a lot about like the tenancy model and like multi-tenancy in a big Kubernetes cluster is terrible. Like, it's a scary place to be because there's so many places for you to forget to do something, and all of a sudden you have the next CVE like launched into the world. But so we're going to build these primitives on top of it. for build, serving, eventing. Maybe we'll have other things in the future. And then by the way, we need to route things to it. So like we're going to have an ingress gateway, which Istio is the default one that gets shipped with. And everybody hears Istio and they're like, ooh, awesome, service mesh. And it's like, no, barely. Like we're just using it as a gateway. There's not a lot of cool stuff built around that yet because the opinions about how to like move and route traffic amongst each other is still kind of a scary place. So it's really about like getting traffic to your workload and maybe getting traffic between like workloads that aren't publicly exposed. So it has a space in the eventing world, but most of the time in serving, you're like, hi, I have a public API, please call me. There's this thing called Glue, which I forget who makes it, but like they've got a really cool logo, and it's a lighter weight version. If you want to get this stood up, like 6 months ago when I tried to stand this up, like it was terrible. Like, and I know I keep saying terrible, like so like I install Kubernetes, then you gotta install Istio, and like I'm on the master, and like I go out to start up Istio, and it doesn't work. Like the deployment fails. The public documentation has led me astray because we've advanced the version of Istio, but like the version of Istio has moved up, and our deployment file like didn't conform to the new spec. So pull request. Can we just move this? So a little bit of fixing, you can get it running, but Glue's this other thing that if you don't like want all the headaches of running Istio and you don't need all the stuff that provides, Glue's a perfectly valid substitute for that. I haven't tried to run it yet, but it looks super duper promising. So who are the audiences of this stuff? So Glue's new. This diagram's old. There's 4 personas or 5 personas that we kind of try to talk about here. There's your developers. Like that's who you're building this thing for. And they're going to talk to an API that's going to talk to Knative. The folks on the other side, the contributors, these are the nice folks who do open source for you and give you this great thing that is Knative. It's very vendor-driven right now because it's very selfishly focused on like we'd like to build a sellable product. But you can get in, you can like and there was a talk at the DevOps meetup one time about like the first thing you can do when you want to contribute to open source, get involved with the documentation because the documentation is always terrible. And this is a certain cloud company who shall remain nameless. Like we write documentation for people who work at the cloud company. And sometimes it's not always clear to the end users what we're asking them to do because they don't live in this world like we do. And I imagine, and you know, has anybody in the room ever had to like write documentation? Has anybody in the room ever had to consume documentation? Which one of these things do you like to do more? I worked on a project in 2000 where the product functionality changed because the documentation was wrong. And it was easier to change the functionality than it was to change the documentation. Because remember before the internet, we all had PDFs or a printout somewhere, and they were just like, yeah, we're just going to make it match the documentation. All right, off of that tangent. So your end users are going to talk to some sort of an ingress gateway, Istio, or they may talk to something that's not even on this picture that's going to ship things into the Knative world. And then your operators are going to worry about keeping your Kubernetes up. They're going to worry about, like, how do I configure Knative? How do I configure the things I want Knative to do? There's a world of people somewhere in between the operators and the developers, probably some developers in the operator world, that are going to build this API, or they're going to decide what we want to expose. Because it's really all about, I go back to this one, like this is your opinions. This is what your culture needs you to do. So Target, really, really good at this. You can take somebody else's version of this, but the reality is not everybody's process is going to be the same. What works for Merrill is not going to work for Google, it's not going to work for Target, it's not going to work for Best Buy, it's not going to work for US Bank. It's not going to work for Three Bridge. So let's talk about what these primitives are. So build, serving, eventing. Like these are the 3 big things. Build, obviously, I take something, I turn it into something that is deployable. So this is source to container orchestration. Serving, I got something coming at me, and I'd like to have something running and maybe help you use it. And eventing is not everything in the world is an HTTP request. So there has to be other ways to deal with things. So let's talk about build. And this is where we're getting into, I read the documentation, so it may be less fun from here on. So the build is about defining a process that runs to completion and can provide a status. So did I build something, or did I fail along the way? The goal here is build a container image that I can deploy to Knative serving, and maybe I route traffic to it, or maybe I send events to it. So that is a special object we will talk about in a bit. And has the ability to use a predefined Kubernetes concept called a service account to connect to something. Like maybe your source code shouldn't just be pulled by anyone. Maybe your GitHub repository should know who pushed the image that was created, such that it's not like picking up a USB stick off the floor or off the street and plugging it into your computer and going, malware? I hope not. Credit to Josh McKenty for that joke. He had a much less safe for work version of that. So the build is made up of a bunch of other things. What's most important on this slide is, hey, you might need some source something. We can take something from a blob store. So the currently supported one is Google Cloud Storage. Maybe I need something that talks to get source code. Or maybe I need to do something special. So by the way, both of these things are built from custom things. We just don't expose it. So you can build a container image that knows how to go out, use that service account, connect to something, and get the thing that you need to turn into something else that's ready for Knative to use. And then there's this thing that's called a builder, which this is a container image that's going to do something as part of the build process, one of which is a source code. So there's a lot of dogfooding that happens in this project, where these base primitives are sometimes used to build other things. I didn't go to the this is the lowest level thing, and you need to go from there. And then this is what happens when the person who reviews your content doesn't know what the content is. So the service account is going to be the privilege that you run things with. And then there's this volume thing. So you get a default workspace when you're building something. So there's automatically a volume mount. But maybe you want to do something particularly tricky, like I have multiple steps, and I need to move state between them. Like this additional volume is useful for that if you want to do something that's outside the scope of the workspace. And the best example I can think of this is folks who worry about Java things in the room. Raise your hand. Who uses Maven or Gradle? Like the Maven logo repo, you put that on a persistent volume, and then you mount it. So every time I build something, I don't have to go get the 8,000 things that any Java thing needs. And then there's this thing that's a timeout. How long should it take? That defaults to 10 minutes. So is 10 minutes too long for your build to take? Everybody in the room was like, well, maybe. Maybe not. Remember, the resource also has to be scheduled during that time. So if it takes time to spin up or go get your container image and spin it up, all that is you're on the clock. 10 minutes is probably a fairly safe default unless you're trying to build a fleet of microservices into a bunch of containers, because you can composite all these things. Don't composite the things. The worst part about Cloud Foundry was we're going to talk about microservices, and we're going to do microservices. And then you looked at the Java build pack, and it's wow, monolith. Why did we handle every Java possible combination? Why did we not do this smarter? Because we wanted to make it easy and super complex to fix. So then the last thing is there's this thing that's called a build template. What a build template is you can define what a build is, but maybe you'd like to make something reusable so you don't actually you don't have to have all this verbose YAML lying around, or you don't have to make all the same API calls all the time. And so it's just a way of encapsulating something for reuse. And so one of the steps you can do in a builder is you can go out and you can create a Docker container image. Well, you're going to do that a lot. So maybe you should just build that into a build template and say, this is the image I want to create. This is where to get the stuff to use to create the thing. Where's the Docker file? And so there's a pre-built one of those. But that example of reuse and consistency is so when you create a build, you can just point it at a build template and give it the parameters, and you don't have to have all that verbosity. Because verbosity is good because I can tell exactly what's going on. Verbosity is bad is because you're going to screw it up. Somebody's going to screw it up and go, please come help me. What have I done wrong? It's similar to the compile phase of Heroku and Cloud Foundry build packs, where its end goal is to produce something that's runnable or a container. It doesn't actually have to produce anything. It can just spit out a log file and say, hey, I ran. Worst hello world example ever is in the documentation where it's like, I created a log thing, except for the fact the thing that creates the log runs so fast that the log actually never ends up getting created. Like, it's up, it's down, no logs. Maybe put a sleep in the example they give, because it makes it a little more interesting. But the idea is, like, there's consistency, there's constraints, and there's something you want to reuse because it's good for the operators when you do. And then you have the choice of like how much multi-tenancy you want to have. Like, you can limit it by namespace. And so this is like all Kubernetes is a multi-namespace thing. By the way, it doesn't do a lot around role-based access control. Like, when you set this up, like cluster admin, woohoo. No, cluster admin bad. The whole point of this is just like, that's your first clue, by the way, that you don't just want to turn this over to people, is because like the turndowns you need to do on the role-based access control, like, there's not a lot of thought put to that, because like the thought is like you're going to have this super user that knows how to do things, and you're going to define that like once or twice. And then there should be something else that enforces like a namespace that you're allowed to do things in. That's that higher level layer. But you can also make things fleet-wide by having a cluster build template. So like you can just call it a build template. You define what namespaces it runs in, or you can run a cluster build template, which is like, hoo-hoo, everybody can have it. So that thing that creates Docker container images probably should be a cluster build template. Serving. Obviously, like rapid deployment of serverless containers. You can, like, because it's Kubernetes, you can step around and you can do things with like persistent volumes and that. But this is not real. Like, you're not running your database here. Like, you're gonna run that someplace else where you're really good at running that. Scaling up and down to 0, point-in-time snapshots of deployed code and configurations, which enables rollback. And then there's this loosely talked about thing, like this is where observability lives, is because this is where things are actually running that are under your control. And this is where you actually want to know about what's running and be able to troubleshoot. There are logs of other things that happen, like the eventing stuff. But like most of that is like, the example I'll use is when I was a Java programmer. I worked with a lot of Java programmers who would write unit tests of their ORM mappings in Hibernate. And I'm like, do you think Hibernate shipped this code and it didn't work? Like, why are we writing test cases to test that Hibernate works? Sorry for those of you in Java who, like, I just had a real painful moment for you. So there's 4 components here. There's the route, which is how do I get to the thing? And how do I get to the thing I want? It's not illustrated on this open source provided document, but the route maps to a revision. That route can go to multiple revisions, and you can have revisions that are out there that aren't being routed to, but those are going to behave in a kind of special way, which the immutable code in container config is a revision. That's not actually what you That's not actually what you deploy. You deploy a configuration, and then every time you change that configuration, it's named the same thing. It generates a new revision of it, and it gives it it names the container and it names the build, or it names the deployment to be something. But so when you're in the revision world, if you don't have any traffic going to you, like, we're actually going to automatically scale you to 0, because like, if no traffic can get there, I'm just not going to leave you running around. There is the concept of like I can leave some stuff running, like I can say a min concept, because that all comes from Kubernetes. But we're going to delete all those resources, but it's all lying around there. And like, if traffic manages to reach it somehow, because you change the route, and or like, oh my God, that thing I just deployed, like, people hate that. You can actually roll back to it, and so you don't actually have to do a subsequent push. All you just need to do is map the route back to it, and it'll start back up. And then the last thing is there's this hyper thing that's the service, which is like, maybe you just want to write one file that does all this for you. Probably not, like, because blue-green deployments with a service thing, maybe not. So let's talk about logging and metrics, because everybody likes to know how the sausage is made. Knative uses FluentD. By default, it has pluggable logging information, logging observability implementations for Elasticsearch and Kanna. That's the one we most often ship. but there's a way to do stack driver because Google was involved, so like we'll just write one. Or you can write your own logging plugin if you have something else beyond that. I don't like who's using something other than Elasticsearch and Kibana right now. Grafana, like there's some Grafana stuff you get out of the box too for metrics observability. But the idea is like there is a definition of how logging should work in Kubernetes, and you can just write your own plugin for there. Because this is important, because when the thing's not working the way you think it's running, like it's slow, let's figure out why. All right, eventing. We're now into the great uncomfortable zone, because this is the least defined thing, and there was a major new abstraction added here between 0.4 and 0.5, and 0.5 was published on March 9th. So like hot off the presses. Well, maybe not in the open source world, but like in 2000, like wow, hot off the presses. So eventing is about composable primitives for late binding things together between things that produce things and things that would like to do something with those things. The consumers can be other services, and this is like this is the first place where we're going to encounter, oh, I might want to dog food things, because maybe I'd like to, as a response to an event, create new applications without modifying the event producer or the event consumer. So when you're building a PaaS, somebody checks in some code. I need to build that code. I need to deploy that code. That's an event. And maybe we should have a construct that says if we're building primitives for building other things, we have a primitive that supports building those other things, not like, well, good luck. Hasn't always acted that way. And then be able to select and target specific subset of events from their producers. The 0.5 release made this dramatically better. This was like, when I looked at 0.4, I was like, this is crazy. Why would anybody ever do it this way? And then we conform to the Cloud Native Computing Foundation Serverless Working Group spec for what a cloud event should be. I'm not going to go into that. It is a very boring piece of documentation, but essentially there is a header, there is some body, and there can be some other attributes that are associated with it. That's important because when you do filtering, you can use those things to decide how to filter, but not all of those things. The message body, like don't filter on message body. Like I think we learned that lesson some time ago. So these are the 0.4 things. So I've got a source, which is something that's going to pump events at me. The most interesting of these things is listed first. Oh, I can consume Kubernetes events? Because, like when I'm building a platform as a service and I want to see what's happening with my platform, like Kubernetes is going to emit events based upon what I ask it to do. And that's really all you're doing is asking Kubernetes to do things for you. You just happen to have different ways of doing that. Kafka, GitHub, GitLab, Bitbucket, write your own. Like there's a way to go out and watch. There's an event that's emitted when an object is changed in a blob store. Those aren't built yet, but you can do that. The service. So this is the thing that is going to respond to your thing, and it's going to behave one of two ways. I'm going to allow you to address me, and I'm going to say, I got it. That's all I'm going to do. Or I'm going to return to you, I got it. Whatever you asked me to do, I did. Or I didn't. 0 and 1. Dig through the log files. But these are services that run as deployables in the serving platform. So there is an interesting bunch of stuff that actually happens behind the scene in the data control plane where events that may end up eventually riding on a channel, which is pluggable in the back end either as an in-memory store or something like Kafka, PubSub, or write your own message provider, gets converted into an HTTP event that can actually reach your service. Remember when we had those revisions that scaled to 0? Those things are still reachable, but and I was referring to the specific, I don't have any magic traffic. Like you don't actually have to have a mappable route to your service in order for an event to get there, because you probably don't want one. Like I have things that respond to web traffic, and I have things that respond to event traffic. Those aren't always the same thing. Events being the special category of things that aren't like humans clicking on a browser somewhere. So the channel is the thing that carries it. And I got a diagram next that talks about this. And then a subscription that says, hey, I'd like things in the channel. So does anybody see anything wrong with the diagram that's up there? Because this is what we addressed in 0.5. The first thing that struck me was, so how do I discern between, how do different events, like, by the way, the color-coded things are event things, and this is the open source segment. Like, do I actually have to have a channel per event type? Yeah, you kind of do, because we didn't really put a thought about, well, you don't actually have to have a channel per event type unless you're going to have different subscribers for it. So like the idea is like the channel is going to give the subscriber all the things that are on the channel, even if you don't want them. So bad platform practice, like that means the application developer has to care about events they don't know what to do with, because like the best way to DDoS yourself is to like put all the logging events on a channel and then like let it call the thing that like doesn't know how to deal with logging events. So this is the thing, like how channels and subscriptions work, where like this is just a different diagram of it. But back to this point, like let's talk about what we did in 0.5 to fix this. This is how the Datapoint works. Channel subscribers run as processes in a pod. They have a sidecar that converts it to HTTP so it can reach the end service. But it doesn't actually have to be addressable. Like that's the important stuff to remember. The channel receiver is a custom implementation that runs in the pod that says things that run there, like maybe I'd like to persist it somewhere and do like something like, I don't know, have it like guaranteed delivery. I don't know. But like the default one we're going to ship is in memory. So like good luck if that pod needs to be moved or restarted. But cloud events are always HTTP post requests. So like your event handler needs to be able to handle HTTP posts. Good news, like easy to find people who can do that. There is an increase, because the Cloud Event Protocol, or the Cloud Native Computing Foundation Events Working Group says you can use multiple protocols. That's work that's going to be in process. But right now, like everybody knows how to do HTTP. So this is the 0.5 stuff. So hey, we have this ability to do brokers and triggers, which a broker is now like, this is a mesh of events. So what actually, broker is an abstraction that sits on top of channel. And so for every new event you add to the broker, and or every new subscriber or trigger that says, hey, there's going to be a thing that comes to me that is of this event type, the broker's going to recognize that and then create a channel. So like you still like kind of want to have a channel per event type in this model, but you no longer have to like worry about creating lots and lots of channels. The broker is going to do that for you, and you're going to tell the broker how you want a particular event type's channel to be manifested. So maybe there's things you actually don't really care about. You can throw them on the floor and not worry about. So you can implement that with an in-memory channel versus like maybe you want to have something that is actually backed by Kafka or something else. And then the trigger is just a different way of describing how to have a subscriber to something. And it has filtering based upon the event header, so that you can say, I want this kind of event, but not that kind of event. So it's 7:30. Talk. Before I go into config samples, because I've just been talking super fast and Bridget's been waving back there frantically saying, slow down. Does anyone have any questions about things I've talked about on the way? I don't actually have all the answers. But I have to give this talk again in a month. So it'd be really awesome if I knew what I was missing.
You talked about how Knative takes some initial source and builds that into something else. Where is that stored? Or, how is that stored? The intermediate, that thing that, so Knative takes source, transforms that somehow. That has to be stored somehow, and then serve or roll out in containers to Kubernetes. How does that happen?
Yes. So the question was, because Bridget always reminds me to do the proper things. So the build process takes some sort of source and builds it into a container image that needs to be served somehow. Thank you for pointing that out. There is a notion that there is a container repository that lives somewhere that you can point at. It may be something running in your Kubernetes cluster. It may be something running somewhere else. But that container does need to be stored somewhere such that when you get to the deployment step, you can actually take that and push it out. Thank you, Aaron.
clarify then, someone else has a question. And my question is, I feel like if I was daydreaming at the beginning of this, I may have missed exactly when and who and why do you choose to use this?
So the question is, why would I choose to use this? And we actually, after we walk through the config samples, or if we don't, like I have a slide that gets back to why would you choose to use this. I'm building a platform, and I want to build something that's special for someone else to use, and I want to make it easier for them to consume. So Pivotal has Project Riff. Rumor on the horizon is OpenWhisk, which is another function as a service platform, is moving to this. I assume at some point in time, Microsoft will have some sort of a as-a-service kind of thing that's built on top of this. We have something that's called Cloud Run that is built on this, which is going to replace App Engine, and our function as a service, where like you probably won't notice that there's a difference in those things, but how we actually translate it to what happens in the background is going to change. One of the things that is really awesome about this is you can decide how many instances of this platform you want to have. So depending upon what your tenancy needs are, and I totally glossed over this. This is something Dan Woods is really big on. Like small clusters are better than big ones, particularly when there's a networking like upgrade that happens. I like read Dan. Well, I don't know if Dan's still on Medium because he's in politics now. Like every time Dan gets a job in politics, Dan disappears everywhere but Twitter. But he wrote this Medium post that talked about this horrible thing they had where they upgraded their networking and they lost some things. And then the etcd clusters started failing left and right, and they lost dev for a couple days. And it was like the worst week of some people's lives.
And we'll be getting details from one of his now former colleagues at DevOps Days Minneapolis this year.
Yes.
Infrastructure, cascading failures, hilarity, etc. I think we have another question.
Hi. You mentioned Istio and Glue for ingress, but is the traffic shifting and blue-green deployments, is that handled by Knative or is that handled by Istio, or what's the integration there?
So the question is, how is traffic shifting managed? Is it Istio? Is it Glue? I just changed my password because I entered my password somewhere else, and Google like knows when my password's entered somewhere else. So is it like, so Istio and Glue, are they doing the traffic shifting, or is it Knative that's doing it? Istio and Glue are doing the traffic shifting. So they're taking the ingress and mapping it to the thing on the back end that's running it. But what Knative is doing is it's API driving those mappings in those other frameworks. So there is a expected like API that those are going to provide. And so like if you want to go out and you want to choose your own web load balancer and write it into a container, like all you have to do is conform to the spec and make sure that it has the ability to respond to those events when they are published. So the answer is like you're using this other layer to do it, and you can choose to use other ones. They just happen to choose Istio because it's in the Kubernetes community.
I think you have a few more slides, and then you're going to come to an exciting, stunning conclusion, and then everyone will bring you their individualized questions as is traditional.
Yes.
But we have a bit more slideage to go through, but not an infinite amount. So.
Yeah, we'll walk through. So there's actually one more slide, and then I have a bunch of references, which really doesn't matter because thou shalt not share these slides. Choices were made. So what I did here is I went out and I built versions of things and then abstracted them in terms of like what actually happens when these are the custom resource definitions that you can use to do things. So this is a build. What you'll see is you have to give it a name and some metadata. It likes to know where to get the sourcey stuff from, and then it likes to know how to do things. And the things it needs to do, as I referenced before, are like they need to be in a container image somewhere. And then you can pass things in. This actually doesn't exist anywhere. I would never write this. This is actually, there's a builder called Kanna that Google uses to create Docker images without a Docker engine present. And so what I did is I went in and I said, well, this is what a build would look like if I did it stupidly. The actual thing you should use is the build template. And so this is the Kanna build template, which is surprisingly similar, except for it's going to describe what the parameters are and then allow you to exercise them down here. So this is probably what you should use. What you would do instead with a build from template is, opposed to having steps, you have a template object that says, I want to use, name this template, and then tell me where to find it, and then what arguments do you need to pass to it. Sorry. The Kanna, you just do it by name because you actually have to register the builders. So that other custom resource definition, somebody has to install that and decide whether it's a cluster build template or a build template, and then others can use it in a reusable fashion. Build make sense? So let's serve some things. This is how you deploy a container. This spec here where it talks about container, that is replaceable with build. So you can actually say, every time something triggers my build, because it's, or creates a new build, because triggering is not actually built into this. So every time there's a new build, that will actually create a new revision by updating this config. So every time you call Kubernetes apply on this, you're actually going to get a new revision of the thing that's named blue-green demo here. And then you might like to get some traffic to it. So this is how you do, and once again, you can put all of this in a single service file, but don't put it all in a single service file, because you're going to change this thing every time you do a deployment. Unless, who sees the flaw in my logic, Brian? Eventing is a case where you're not actually going to have a mapping, because the system's going to figure it out on its own. So this is just like whatever the revision name is, you're going to need to figure out what that is. It will default to the latest revision every time, but we have a named revision in this, because when we actually do a second deployment where we create a green version of this, we might actually want to do something like a 50-50 split, or a 50 or 100-0. So you can do a 100-0 split here, and that this is still reachable. It will dynamically create a route for you that's not the thing you want to be reached at, such that you can still call it and test it's ready. So before you actually change this from 0, you might want to do some testing in your private environment. So still publicly addressable, but it's not going to be at the primary URL. The other thing that's weird about Knative is you're going to reach this thing at blue-green demo.default or .namespace .example.com is what they ship by default. This was really, really hard to figure out in October. Like, how do I have a custom domain for this? It's much easier now. There's documentation on it. The other thing I will say is, like, so if you're thinking YAML, like, who's going to do all this stuff with YAML? There's a company called Stark and Wayne. They do consulting. They're actually writing a CLI for this. And so if you want to learn how things work, just like Dr. Nick Williams writes lots of awesome stuff. All right, so last thing I want to walk through is we'll walk through eventing. Which one of these do I want? We'll just go immediately to brokers, because like we don't need to go to things we don't need. So this is a broker. What it does is you're going to give it, like, what's its name going to be, and then what's its channel template going to be. I might have implied earlier, because I did imply earlier that you could have different channel templates. I've actually not tested that. I would assume we would at some point in time, where you can have different kinds of events ending up at a broker and ending up on different kinds of channels. Channels are important. You might want to configure one of those. This moves so fast, I hardly even know it. This is just an in-memory channel, but you can give it other names. PubSub is one, Kafka is one. So, choose your message broker of choice. And then you're going to want to have a trigger, which it's just a different way of writing a subscription. But it basically says, what kind of event do I actually want to get, as opposed to, like, give me all the events. So because I know people want to get going, I'll hop back to my slides. But like the last thing I wanted to talk about is, remember, like, the more control you give your devs, the more sadness they're going to have. They're also going to like to do, like, they're going to like it, but there's going to be a point where they're sad, and you're going to be like, oh, I wish I wouldn't allow them to do that. So remember, this is something to build something else. Choose, with great power comes great responsibility. Decide what you want to give to other folks to use. So in my presentation in a month, we'll actually have like real things. Maybe, because I got to cut some things. Any more questions before we finish off the bar?
And if we have a couple more questions.
I was actually confused between the template build. Can you go back to that?
Yeah. The config sample?
The recommendation was to use the next one, right?
The build template?
And then you jump to that one.
So, so I'll go all the way back because I've obviously, I jumped through these really fast. So this is a build which specifies.
Can you blow them up a tiny bit? I was way in the back and it was super hard to see.
Yeah. Maybe not that much. Maybe more, though. So there's a bunch of stuff about name and metadata. So in the steps section here is where you describe what it is you want to do. So the difference between a build and a build template is a build is a single use thing. It's a specific source to a specific thing. What a build template is it's an abstracted version of this where, see these arguments here? I can substitute parameters that somebody passes in when they call the build template, but you still call it from inside of a build. You just don't have steps anymore. You use a build template where somebody else has already defined the steps. Does that make sense? Yep. Awesome. Thank you.
Okay. I think we have one more question, and then we're going to come to the traditional part where everyone asks the speaker to ask the questions individually.
That's because so the question is, where does Istio come into play? So Istio isn't used a lot into this. It is used to map traffic to services. So when you declare a route, Istio is exercised to create the mapping of the edge node that's running. So there's a pod that runs and like a load balancer that figures out, based upon the URL that is submitted, what container images can support that, or what running pods can support that. So that's what Istio does for external web traffic. It's also used to map traffic when you subscribe to a channel and have an event directed at a service. So that's the two pieces that Istio is used for. It's not used for all the cool, complicated stuff like HTTPS or all of the SSL load balancing, or not SSL load balancing, the SSL connections between things like you might do with individual certificates. Yeah, it's not. So it is going to do some of the retries. It's also the thing that's going to sit on the edge when you're scaled to 0 and catch that thing and go, I'll hold on to this till the pod is ready to start receiving traffic. Because when Kubernetes starts that up, an event's going to be published. Knative is going to catch that event. It's going to tell Istio, I'm ready to take that, so let me have it. It is a freestanding component. So the question is it the route box? It is something outside of the Knative world that is exercised by Knative to get traffic to the running services. So you still have to deploy it. You deploy it first, actually, before you deploy anything in Knative. Super.
All right. Please give it up for Andrew Ripka.